Hello everyone, let's practice solving some trig equations. So you're either going to need to factor or it's already been factored for us. It says find all solutions and this one's already factored. So remember use the zero product property. We're going to set each factor equal to zero. Either the cosine of x is zero or 2 sine of x plus 1 is zero. So that means this would solve to negative 1/2. So let's figure out where those things happen. Cosine is 0. The cosine is the x. That happens here and there. So this is at, remember, 0, 1, and 0, negative 1. So pi over 2 and 3 pi over 2. And sine is negative 1/2 in the third and fourth quadrants with 30-degree reference angles. So if we list them all out, we'd say, all right, let's do this guy. This is pi over 2, and I'll put plus pi in. So that also takes care of 3 pi over 2. And then we'll say 7 pi over 6, and that's not something I can condense. 7 pi over 6, this isn't pi across, so we'll just say plus 2 pi. And then we'll also say 11 pi over 6 plus 2 pi. So those are your solutions for that. You just had to set each factor equal to 0, and once you have that, you just write them out. So nothing too fancy just yet. Let's keep moving along. The giveaway for the second one that I know I have to factor is that I have a sine and a cosine in the same equation. So I'm going to look for a GCF, which would be cosine. So the cosine of x is going to get factored out. And now I have the sine of x minus 2. If you factor out the cosine, you have sine of x minus 2. So that means either the cosine of x is 0 or the sine of x minus 2 is 0, which, wait a minute, that means the sine of x is 2? No, it's not. Remember, sine, the largest sine we'll ever get, is up here, 1 to negative 1. So sine will never be 2. But cosine will be 0. That's actually right there. So I can just say my solution set is pi over 2 plus pi n. It's the same values we had on this one. Pi over 2 plus pi n. Okay, cool. Sometimes you'll have a factor that doesn't really help you. Not a big deal. Just know that it can happen. This one's already factored, so we'll set each factor equal to 0. So that means that the tangent of x would be negative radical 3, or cosine x plus 2 equals 0, which means the cosine of x is negative 2. Again, no, it's not. Cosine, the smallest cosine gets is negative 1, and the biggest it gets is 1. It's never negative 2. So where is tangent negative radical 3? You should remember that if tangent is radical 3, it's a 60-degree reference angle, and tangent is negative in these quadrants. So with a 60-degree reference angle, we can just say x equals, this is 2 pi over 3, and since it's straight through, we'll throw pi n on there. 2 pi over 3 plus pi n. That gets both of them. Number 19 here, you can see that you have a cosine squared and a cosine. So this is where I'm going to do my substitution. Instead of writing cosine squared, I'm just going to say u squared. So the cosine of x, I'm calling u. That's a u. Now we'll split the middle. So what multiplies to 4 and adds to negative 4? What multiplies to 4 and adds to negative 4? How about negative 2 and negative 2? That multiplies to positive 4 and they add to negative 4. So then when I do my factoring, this is a perfect square. 2u minus 1 minus 1. 2u minus 1. So it's 2u minus 1 times 2u minus 1. We'll just write it in squared. To solve that, if that factor equals 0, you would add 1 divided by 2. And I need to figure out where the cosine of x is 1/2 because u is 1/2. So let's draw our little graph here and figure out where cosine is positive 1/2. Cosine is positive on the right side, and that means it would be the short leg. The x is the 1/2, then the long leg is the radical 3 over 2. So this is a 60-degree reference angle. So we'll say x equals, I'll say pi over 3 plus 2 pi n, or this would be 5 pi over 3 plus 2 pi n. If you wanted to put like a fancier version, you could say plus or minus pi over 3 plus 2 pi n. That also works. As long as you are careful, you can sometimes condense these. But make sure if you're going to condense them, you do it right. Okay, if I can look at it and those aren't right, then you're not paying attention. So this is good. This is a little bit better. Last two. First one's already factored, so let's set each factor equal to 0. So let's see, that would mean the cosine of x is, you would subtract radical 3 and divide by 2, or the sine of x is 1/2. So where does this happen? Cosine is negative over here, and if the x is the long leg, then that means we're talking about 30-degree reference angles. So that's where cosine is, negative radical 3 over 2. And sine is positive 1/2, actually right there, but also right there. So this one's kind of weird because it doesn't really have the symmetry that some of them have. I kind of like it. So how can we write this out then? We'll say 5, why is it not? And 5 pi over 6 plus 2 pi n. So 5 pi over 6 plus 2 pi n, that gets that. And then this, I can say 7 pi over 6, but since 1 pi over 6 also works, I can just say plus pi n. And that picks up this guy. This should be straight, but I didn't draw it in one segment, so it doesn't look quite right. So 5 pi over 6 plus 2 pi n, because you don't include this one, but 7 pi over 6 plus pi n, because you do include this one. But again, this is supposed to be a straight segment. One more, I see that I have some sine squared and some sine to the first, so I'm going to say 2u squared minus u, and I'll also have to subtract 1 before I factor. Now I find numbers that multiply to -2 and add to -1. So that would be -2 plus 1u. They multiply to -2 and they add to -1. Then when I do grouping, u minus 1 plus 1, u minus 1. So that means that 2u plus 1 or -1 are my factors. So u is either -1/2 or 1. If you solve these for 0. And since u is sine, that means the sine of x is -1/2, or the sine of x is 1. And we got to figure out where that happens. So sine of x is -1/2. That happens here. We'll say 30-degree reference angles like that. Or sine is +1 up here. So this kind of has a cool look to it. So we could say pi over 2 plus 2 pi n. And then this would be 7 pi over 6. And then this would be 11 pi over 6. And since none of these are pi across, we're not going to do pi n. You could actually condense this if you're clever, because look, this is 90 plus 30. That's 120. And this is 120, which means that's 120. So they're all 120 apart. So let's start at pi over 2 and then add 120 degrees, which is 2 pi over 3 radians. That's the fancy version. Start here, add 120 as many times as you want, which is 2 pi over 3 radians. So you've got all your practice problems. You've got your completion folder to make sure you get done. That's all the hardest solving, and that's really it for the unit. So if you can do this, go through your study guide, start hitting the books. It's time to get going for the test. Hit that like and subscribe, and good luck.